Previously, we've talked about alkanes, alkenes, and now we're going to talk about alkynes. Alkynes are hydrocarbons that contain a triple bond. An alkyne has the general molecular formula of CnH2n-1, and remember that the triple bond means that there are 2 degrees of unsaturation, which means that there are 4 hydrogens that are missing. As alkenes, we can also have terminal alkynes that have the triple bond at the end of the carbon chain, or internal alkynes that have the carbon within the chain. Remember that a terminal alkyne, just like this one, will have an H right there, and that's important for the synthesis of involving alkynes. We've seen this before, but let's just review that a triple bond, just like this one, it's made of 2 sp hybridized carbons. And remember that sp hybridized carbons, they have to be 180 degrees apart from each other. A C triple bond C is made of 1 sigma bond and then 1 set of pi bond and another set of pi bond. And as you see here in the picture, the 2 pi bonds are 90 degrees away from each other. As I mentioned before, the pi bond is not as strong as the sigma bond. And by looking at the bond dissociation energies, we can establish how strong is the second pi bond in the triple bond, right? So we can look at how strong is a double bond. Then we can subtract the double bond from the triple bond, and that will give us the energy, the bond dissociation energy of the second pi bond on a triple bond. As in the case of cycloalkanes, cycloalkynes also exist, but the small rings are very unstable because of the constraint. So the smallest possible ring that contains a triple bond is going to be made of 8 carbons, and that's cyclooctane, and that's the smallest isolated cycloalkane. But the problem with it is that it decomposes upon standing because of the high energy constraint. So the larger the cyclic ring, the better to accommodate that triple bond. We talked about alkynes briefly when we talk about nomenclature, and alkynes are just named in the same general way as alkenes are. In the IUPAC system, remember that instead of having "ane," when we have a double bond, we will end it in "ine." And now when we have a triple bond, we're going to use the suffix "ine," this one right here. So in order to name a triple bond, what we'll do is that we'll choose the longest continuous chain that contains that double bond. And then once we find that longest possible chain, we will number our chain in a way that the double and the triple bonds contain the lowest possible number. Let's look at some examples here. So for example, in this one right here, we have the longest possible chain will be this one right here. And now we have to choose the one that will put the double bond in the lowest possible position. Sorry, not the double bond, the triple bond. So in this case, 1, 2, 3, 4, 5, 6, and 7. You see the triple bond ends up being on 3. And we have the substituents, the 2 dimethyls, in 2 and 5. In this case right here, we cannot, by any way, we cannot put that triple bond in the main chain. So in this case, because we don't have a name for this substituent, we have to name this triple bond as a substituent. Then here we have 2 triple bonds. You see, if we start from this side, 1 and 3 are the numbers associated with the triple bonds. If we start from this side, it would be 1, 2, 3, and then 4 and 5. So 3 and 5 are not the best. they are not the chosen ones because 1 and 3 are smaller numbers. And the same happens for this one here. Here we have 1 and 4. And if we started from the other side, it would be 2, 3, 4, 2 and 5. So because of that, we start with the 1 on the left side. And some of the physical properties of alkynes are the same ones as the ones for alkanes and alkenes. They have low melting points and boiling points, and as we increase the number of carbons, their melting points and boiling points will increase. Alkynes, as the other hydrocarbon chains that we've seen, are soluble in organic solvents, but they are not soluble in water. One alkyne that we're gonna see often, especially in this chapter and in the upcoming chapter of synthesis, is the simplest alkyne, which is ethene, but it's often called acetylene because it's its common name. It's a 2-carbon alkyl group, and it exists as a colorless gas that burns with oxygen. When it burns, it has a very hot flame, and it's used in welding, or it's some people have it at home for barbecues and for use at home. You may have seen it in a small bottle, and when it burns, it has a strong blue flame.